This video is going to be an explanation of the source of our resonant power on our electrical amplification system. We're actually deriving the energy from the vibration of the armature itself without a magnetic field present. As you can see here, we've removed a stator housing from the armature where we've just got the armature of the DC brushed motor without the magnetic field. We're connected like we are in the other videos with a connection from the casing here on one output of the transformer. The other output is connected over here. You see it wind around here to the junction between these two capacitors here. The capacitors are wired in series. The diodes are facing in opposite directions. The positive terminal of the capacitor, the diodes are facing in and are connected to the terminal of the motor here, the red wire terminal. On the negative side of the capacitor, the diodes are facing outward toward the black wire of the terminal here of the motor. When we energize the system at its resonant frequency, it charges one capacitor, and then whenever the alternating current flips, the opposite capacitor is charged. So that's how our circuit operates. The actual core of the motor, the casing, which is aluminum, transfers energy through the bearing, the actual armature bearing, and oscillates the armature. So induction takes place with the ferromagnetic domains that are in the armature itself, and when we tune to the resonant frequency, the voltage just shows up on the windings themselves. Over here, the capacitors are connected to the motor terminals here and here, and then we have a light bulb which is connected in parallel with the motor. So whenever we turn on the actual system itself and start tuning it, energy will flow from the armature domains themselves to the capacitors and then to the load, which in this case is this motor here, which has got a coupling on it. So when we start it, you'll hear the motor start to rotate, and we're going to tune it right here with this variable resistor, which changes the frequency of our oscillator chip. So we'll come down here, and as I start coming toward the resonant frequency, in a minute, we'll see the motor start to rotate. You'll hear the motor pitch increase in RPM. The closer we get to the resonant frequency of the actual armature itself. You're hearing the motor pitch increase more. And then here we are. And all of this while there's no motion at all, but electromagnetic induction is taking place actually in the armature of the resonant system. It's the circuit that works, and it's how the circuit is designed to tune to the resonant frequency of the armature. So we're charging both capacitors at a very high frequency and rectifying them through the diodes and in the circuit. If we come over here now, we're going to detune it, and we can hear the motor RPM back off. And you see it slowing down. Like an airplane engine winding down. And it's come to a stop. So this is how the resonant system operates. Electromagnetic induction is taking place actually through the vibration of the armature itself. So we just wanted to give this real quick explanation, and we thank the viewers for watching.